Alright guys, welcome to Math 0106, Lesson 3. This is going to be the second part of prime factorization. I'd asked you guys in the last video to try to do the prime factorization of these last couple problems. Now we're going to go through it together, make sure that you guys know how to do this. So, what is the prime factorization of 25? So the goal here is to think what number is prime that 25 is divisible by. So that hopefully becomes 5, and this is actually just becomes 5 times 5, or simply 5 squared. Okay, 81, again, my emphasis would be on trying to take a prime number, so this would be 3 and 27. 27 breaks down to 9 and 3, and that breaks down to 3 and 3. I want you to note that if you were thinking 81 is 9 and 9, and then 3 and 3, this would be fine as well. I just like to list my prime factors all on the left side, so it keeps it organized. By the way, also the answer here is still 3. We could rewrite it as 3 to the 4th. Okay, it's getting kind of cluttered here on the page, so for the next ones, I'm going to start writing them down here. So number 19 is 45. So what is 45 divisible by? Well, clearly it's divisible by 5 because it ends in a 5. So that would be 5 times 9. Again, I know I'm sounding redundant, but the key here is that you need to know your multiplication tables, because otherwise this becomes incredibly difficult. 9 breaks down to 3 and 3, because 3 times 3 is 9. Alright, next up we have 12. So 12 is divisible by 3. You could have chosen 2 as well. I was just thinking 3 times 4, and 4 is 2 and 2. So that breaks down to 2 squared times 3. 21, this is where we start to get into some difficult territory. 21 is 189. What number did I say? 21. Okay. So, now 189 is tricky because we don't know, it's not very clear what goes into it, but we can use divisibility rules, and if I do 1 plus 8 plus 9, I get 18, because 18 is divisible by 3. 18 divided by 3 is 6. I know I can divide by 3. We also know it's divisible by 3 because 18 divided by 3 is 6, and 9 divided by 3 is 3. 63 breaks down to 7 and 9. If you know your multiplication tables, you know that. And then 9 breaks down to 3 and 3. So this becomes 3 to the 3rd times 7. Okay, what's next? 22, I can't see. Let's see, 450. Okay. So, let's try to fit 22 in here. 450. So 450, I'm going to say, is divisible by 3, because 45 divided by 3 is 15, so this is 150. You actually know that 45 divided by 3 is 15, because just think of a clock. If you think of a clock, each quarter is 15 minutes, so 3 quarters would be 45 minutes. So, relate to the real world, math is pretty easy. We've seen 150, by the way, several times. 150, I'm going to use is 2 and 75. If you have 2s, I guess the way to think about it is if you double 3 quarters, you get 6 quarters, which is $1.50. If that helps. 75, I'm still thinking quarters here, so this is going to be 3 and 25. And 25 breaks down to 5 and 5. Again, you may have done it differently than I did. That's fine. At the end of the day, we have 1, 2, 2 3s, and 2 5s. And there we have it. So you can see that prime factorization gets a little tricky as the numbers start to get bigger and bigger. 242 is the next one. 242, and I keep forgetting the number. I think it's 23. Just want to double check. Yeah, 23. Okay, so 242. Now, I don't know what 242 is, divisible by other than 2, because it ends in a 2. And this is actually really easy to do in your head, because 2 divided by 2 is 1, 4 divided by 2 is 2, and 2 divided by 2 is 1. Now you may recall, if you've been watching the other videos, we've talked about 121 before. 121 is a little difficult if you've only memorized up to 10. 121 is 11 times 11. 11, by the way, has this symmetrical property. There is, and this is a little math tidbit, but I think it's nice to kind of help you out with certain things. I'm generating something that if you go into any class that has probability, you will see. This is called Pascal's triangle. And the way you generate this is you have ones on the extremes, and you just add to get to the bottom row. So what I'm saying is 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and 3 plus 3 is 6, etc., etc. The reason why I mention this is 11 to the 0 power. Anything to the 0 power is 1. If you get into higher level math courses, you will see why that's true. For the time being, just accept that it's true, or type it into a calculator and you'll see that 11 to the 0 is 1. 11 to the 1 is just 11. 11 squared is 121. 11 cubed is actually 1331. My point is, this triangle develops the powers of 11, and if you're generating, as you generate with this, right, we can clearly see that there's a sort of symmetry, right, that occurs here, and that is always a product of 11, pun intended. So this one is going to be 2 times 11 squared. So it's a little tough, not really tough, but you need to know that 11 times 11 is 121, otherwise this problem's going to be pretty hard to figure out. Okay. Then we have 24, and I'm out of space, so I'm going to erase these. You can always go back in the video to see the problem. Let me create some space. Okay, thank you. Actually, I'm just going to erase all this to make it look clean. Okay, 24. Hopefully I don't have to go too far down. 3, 3, 8. Now this is tricky because you look at it and I don't know, I saw 3 so in the front, so I was kind of saying, hey, maybe it's divisible by 3. It's not. Hopefully you realize that why it's not. If you add the digits, 3 plus 3 is 6, 6 plus 8 is 14. That's not going to work. But we definitely see 2, right, because it's even. So we can do this via long division. 338 divided by 2, 1, 2. 13, this is 6, this is 12, this is 18, this is 9, and this breaks down to 2 and 169. The other way that you can kind of see how to do this is to break it up into 2 parts. Actually, yeah, so let's do it this way first. Then we could divide each of these by 2. So this would be 150. 38 divided by 2, what I actually think is I know 40 divided by 2 pretty easily is 20. So 38 is one less group of 2's, so this would be 19. The other way you could do it is if you took 38 and you broke it down to 30 plus 8, and if you're dividing each of these by 2, you're getting 15 and 4, which is 19. Okay, whatever makes sense to you, go ahead and do. This is going to give you, I don't know why I wrote 2, it's 169, right? Which is what we got here. Okay, now again, 169 is tricky because if you don't have these memorized, you're like, where is this coming from? But you want to memorize 13 squared is 169. As a little tidbit to help you memorize, if you have 13 squared memorized, 14 squared is actually just flipping the 6 and the 9. So that's just 196. Really, it's just, you're not going to know unless you memorize it. So it's a little tough, not because the problem itself is tough, but just because if you don't know that 13 times 13 is 169, you're not really going to be able to figure that out. So, outside of guessing and checking, obviously. So, in any case, there's your answer. I'm going to make this video a little short so that we kind of have all prime factorization kind of grouped together. In the next video, we're going to start talking about fractions. So, hopefully I'll see you all there.